Welcome children, we continue with the chapter on air for standard 7th, and this is the third part of my video, and with this video we conclude the chapter. Now the second factor for weather and climate is air pressure. Now children, let us understand what is pressure. Yes, pressure means a force applied to a surface. You can see using a hammer and applying it to a surface, and I'm applying force to it. Okay, so that is the meaning of pressure. Now children, all of you know that air has weight. How do we know that air has weight? If we take two balloons, one which is not filled with air and the other which I fill it with air and I weigh it, I find the balloon which I filled it with air has weight. So you see, because air has weight, it is pressing, this air weight is pressing on the earth's surface. It is applying pressure. Okay, so the force that is applied by the air on the earth's surface is called as air pressure. You can see air is pressing all around the earth's surface because air has weight and it is pressing on the earth's surface. This is called as air pressure. So you see children, because air has weight, it is pressing us, our humans, also with great force on our bodies. Air is pressing us from the outside, but we still do not feel it. What is the reason? So children, why don't we feel the pressure? It is because that the same amount of pressure is exerted by our body, which makes a perfect balance. So you can see air is pressing us from the outside, but internally our body also has pressure which is counteracting it. Okay, so the same pressure which is from outside, the same is applied from inside our body, so that counters it, and that is why we do not feel the pressure all around us. So children, you see, on moon there is no air and hence there is no air pressure, but human body has pressure inside it. So that is the reason when astronauts have to go to the moon, they have to wear a special protective space suit which is filled with air. Okay, if they do not wear this suit, what will happen? The counter pressure exerted by the body of the astronauts would make the blood vessels burst and the astronauts would bleed. This is the reason why it is so important to wear that special protective space suit. So as you know children, there is an atmosphere all around the earth's surface which is air, and air, as I told you, has weight. It is exerting pressure on the earth's surface. So to define air pressure, we can say air pressure is the pressure that is exerted by the weight of air on the earth's surface. Let us now understand how air pressure causes air to move. Yes, the movement of air is caused by the differences in pressure. Children, you must know that air moves horizontally as well as vertically. So this is horizontally as well as vertically. Now let us understand the vertical movement of air. The vertical movement of air, you can see the vertical lines, is called as air current. You must remember this. Vertical movement of air is called air current. Children, when air gets heated by the sun rays, it expands and becomes light. Now once the air is heated, it rises up and creates an area of low pressure on the earth's surface. Now let us understand what happens on higher altitudes. On higher altitudes, condensation takes place. Why? Because of the low temperatures there, the hot air cools and condenses. Okay. Now once condensation takes place, clouds are formed. So we can say that low pressure is associated with cloudy skies and wet weather. Now children, in contrast to the hot air which becomes light and rises, cold air contracts, due to which they become heavy and come down and create high pressure areas on the earth's surface. Children, high pressure is associated with clear and sunny skies, means no formation of cloud takes place. Children, air pressure is measured with an instrument called a barometer. Children, you must remember that air pressure is highest at the sea level. And air pressure, children, decreases with increasing height. As you go higher, air pressure decreases. Okay? Now children, let us understand the horizontal movement of air. You can see the horizontal movement of air on the earth's surface. Now children, air moves on the surface of the earth from one place to another only if there is difference in pressure. Air moves from one place to another only if there is a difference in pressure. Now, what causes this difference in pressure? Now, this difference in pressure is caused due to differences in temperature. Always remember children, high temperature creates low pressure. Now, why does high temperature create low pressure? Because the air gets heated, it expands and becomes light, creating an area of low pressure. Whereas low temperature creates high pressure because cold air contracts, becomes heavy, and it sinks down, creating area of high pressure. Now children, always remember that air moves from high pressure to low pressure areas, from high pressure to low pressure areas, and this horizontal movement of air is called wind. So children, remember the horizontal movement of air is known as wind, and air always blows from high pressure to low pressure. Let us now study the pressure belts and the wind system of the world. Just a little recap before I proceed. There is a blanket of air that surrounds the earth, which is called the atmosphere. And why do we have an atmosphere? Because of the earth's gravity. The earth's gravity pulls it, and since it pulls it, this air has weight, it exerts pressure. And the air that is around our earth is not constant, it is continuously moving. And the main difference in air pressure is caused by difference in temperature. And due to the spherical shape and rotation of the earth, the different parts of the earth are heated unequally, creating belts of low pressure and high pressure. So let us look into this high pressure belts of the world. Now children, there are 7 pressure belts. First, let us learn the names. Okay, so the first one you can see at the equator, 10 degrees north and 10 degrees south, which is called the equatorial low pressure belts, and this area is also called as the doldrums. Okay, then we have subtropical high in the northern hemisphere and subtropical high in the southern hemisphere. Okay, then we have subpolar low in the northern hemisphere. We also have a subpolar low in the southern hemisphere. Then polar high in northern hemisphere and polar high also in the southern hemisphere. Now look at the degrees. As I told you, equatorial low lies between 10 degrees north and 10 degrees south. Subtropical high in the north is between 30 to 35, and you can see here also between in south between 30 to 35, and subpolar is from 60 to 65 degrees is subpolar, both in the north and south. and then we have in the North Pole between the 70 to 90 degrees we have the polar high. So how many pressure belts do we have? One equatorial low, then subtropical high, two in the northern hemisphere, and subtropical high in the southern hemisphere. That counts as three. Then subpolar low in the northern hemisphere and subpolar low in the southern hemisphere. So that's a total of five. And then we have polar high in the northern hemisphere, okay, and also polar high in the southern hemisphere. So total there are seven pressure belts on our earth, okay. So it is 1 2 3 4 5 6 and 7. Now you must remember that we start with low pressure, then we have high both in the northern and hemisphere. After high there is low again in northern and southern hemisphere, and then we have high pressure belts and the polar regions, okay. So this is alternate low and high. So children, you see that the equator divides the earth into two equal halves, the northern hemisphere and southern hemisphere. Now the equatorial region, now which is the equatorial region? It is between the two tropics, is called as the equatorial region. As I told you, we have discussed it 10 degree north and 10 degrees south, okay. They receive the direct rays of the sun, so making this region very, very hot. Continuously they are receiving the direct rays of the sun. Now, since the equatorial regions receive the direct rays of the sun, what happens? This belt becomes very, very hot. So the temperature rises here. And when temperature rises, pressure becomes low. So this creates a region of low pressure. And that is why this region, this red band belt that you see, this zone that you see, is called as equatorial low pressure belt. So you see children, the equatorial low pressure belt lies between 10 degrees north of the equator and 10 degrees south of the equator. Now this region is also called as the doldrums. Now doldrums means the zone of calm due to the absence of surface wind, and because this region gets the direct rays of the sun, what happens? This area becomes hot and the air here becomes hot and it starts to expand and becomes light and it rises up, so creating an area of low pressure. Now all that hot air from the equatorial low pressure belt rises, goes up to the troposphere obstructed by the tropopause. Here it condenses and cools, and then we will see what happens when it cools. So children, you can see as the hot air rises from the equatorial low pressure belt, it goes up to the troposphere where it cools, and when cool air it becomes contracts, becomes heavy and starts to sink down. So you can see they're sinking down on either side. So this is in the southern 30 degree south of the equator and 30 degree north of the equator. They descend in that belt, okay, both north and south of the equator, 30 degrees north and south of the equator. Now the hot air from the equatorial low rises up, goes up to the troposphere, cools and condenses, and then, as you know, cool air becomes dense and heavy and starts to sink. So it descends here in this region between 30 and 35 degrees north and south of the equator, which is called as a subtropical high pressure belt, both north and south of the equator. Okay, this area is also called as the horse latitude. Now why is it called as the horse latitude? Because in olden days, when the ships were carrying horses and cargo, they found it very difficult to sail in this region because the air was dense here. Okay, and if they were carrying horses, what did they do? In order to make their vessels light, they would throw the horses into the sea, thinking that it is because of the weight of the horses that they are unable to sail smoothly. Little did they know that this was a high pressure belt, and that is the reason, because they threw their horses into the sea, this belt came to be known as the horse latitude. So you see children, this is a clear picture that shows you how the hot air rises, cools and descends at the subtropical high pressure belt both north and south of the equator, which lies between 30 to 35 degrees north and south of the equator. Now what happens between 60 to 65 degrees north and south of the equator? Now here the air that comes from the subtropical high and also from the polar high regions, okay, they come together, they converge, they come together and then they rise up. You can see they're coming together closer and then they are rising up. Okay, so when this happens, this region, that is 60 to 65 degree belt, creates a region of subpolar low pressure belt here as in the north as well as in the south. You can see that the air converges and then rises to form a low pressure belt, and this is called as a subpolar low pressure belt. So you see children, this subpolar low pressure belt which lies between 60 to 65 degrees north and south of the equator. So the air coming from subtropical high and polar high, they converge together and then they rise up, creating a belt of low pressure which is called as the subpolar low pressure belt. Now children, let us see what happens at the poles. As you know, at the poles they receive the inclined rays of the sun, the vertical rays of the sun, so they hardly get any sun rays. This area doesn't get any heat, so this area remains cold and frozen throughout the year, and that is why, since it is cold and frozen, the air here is dense, creating an area of high pressure. So we have polar high pressure at night between 70 to 90 degrees north and south of the equator. So you see children, we have the polar high pressure belt. As you know, they receive the inclined rays of the sun, okay, slanting rays of the sun, so this area remains cold throughout the year, creating an area of high pressure, and cold air is dense, okay, so creates every area of high pressure belts. So you see, now you know all the pressure belts of the world, starting with equatorial low pressure. Why low pressure here? Because it receives the direct rays of the sun, and when it receives the direct rays of the sun, the hot air rises, cools and condenses here in the subtropical high, which is between 30 to 35 degrees north and south of the equator. Then we see the next is the subpolar low, where air from the subtropical high and polar high converge and rise, creating an area of subpolar low pressure belt. Okay, and polar high pressure belt, they remain high pressure because they receive the inclined rays of the sun. So there are total 7 pressure belts of the world. Okay, and equatorial low is also known as doldrums, and subtropical high pressure belts are also known as horse latitude. Now let us look into the wind system. As you know, wind is caused by difference in pressure on the earth's surface. So children, what is wind? Wind is the horizontal movement of air, okay? And always remember that wind blows from high pressure to low pressure. So HP is high pressure and LP is low pressure. Wind always blows from high pressure to low pressure. Wherever there is low pressure, winds from high pressure area will come and occupy its place. The winds are named after the direction from which it blows. For example, the wind that originates from the western side, you can see this arrow is called as west wind or westerlies. So if they are from the eastern side, if they blow from the eastern side, they are called as easterlies. And winds that originate from the south are called as south winds. So you can see this arrow blowing from the south, they are called as south winds. If they blow from the north, they are called as north winds. So depending on the direction of the winds, they are given their name. Now we can classify winds into three types. Now which are the three types? We have the planetary winds, then we have seasonal winds and local winds. So there are three types of winds: planetary winds, seasonal winds and local winds. Now what are planetary winds? Yes, planetary winds are winds that blow constantly in a particular direction throughout the year. So if they are blowing from the north, they will be blowing from the north throughout the year. They keep the same direction. They don't change their direction. They blow in a particular direction throughout the year. Now there are three types of planetary wind. They are trade winds. You can see trade winds, westerlies and easterlies. Okay. Now let us first understand what are trade winds. Now as I know, winds always blow from high pressure belt to low pressure belt. So let us look into the northern hemisphere first. We see the northeast trade winds. Why are they northeast? Because they are blowing from north and east direction. You can see the arrows blowing from north and east direction. They are called as northeast trade winds. They are blowing from subtropical high pressure belt towards equatorial low pressure belt. Similarly, in the southern hemisphere, we see the trade winds which are called as southeast trade winds. You can see south here and east here. They are blowing in this direction. So they are called as southeast trade winds, and they are blowing from subtropical high pressure belt towards equatorial low pressure belts. Now why are they called trade winds? Because in those days trade was carried through sea and the ships could sail smoothly because these winds blow in the same direction throughout the year. Now let's go to the next one, that is westerlies. And in the northern hemisphere we see they blow from the west direction. So in the northern hemisphere they blow from southwest direction. Okay, and this is the southwesterlies which brings rain to India. And they are blowing from, again as I told you, wind blows from high pressure to low pressure. So they are blowing from subtropical high pressure to subpolar low pressure belt in the north. Similarly, in the south we see again wind is blowing from high pressure to low pressure, and in the south they are blowing from southwest. Okay, so they are called, that is why they are, since they are blowing from the west, they are called as westerlies. So you can see they are blowing from subtropical high pressure belt to subpolar low pressure belt, and because they are blowing from northwest they are called as northwest westerlies. Okay, now let's go to the next one, polar easterlies. First let us look into the northern hemisphere. You can see again the winds are blowing from high pressure belt to low pressure belt. So they are polar high pressure belts to subpolar low pressure belt. And since they are blowing from northeast, they are called as northeast easterlies, polar easterlies. Okay, and in the south again they are blowing from polar high pressure belts to subpolar low pressure belts, and since they are blowing from southeast they are called as southeast polar easterlies. Okay, so these are the three types of planetary winds. Which are they? Trade winds, westerlies and easterlies. Now, why were these planetary winds so important to early sailors? Now, when Christopher Columbus, sailed the ocean, for centuries thereafter, ocean travel dependent on wind, and mariners knew how to get there at what time of the year, because they knew that these winds always blew in the same direction throughout the year, and this was useful for the sailors and also helped them in trade and commerce, especially between people who were the opposite side of the sea. Okay. The second type of wind is the seasonal winds. Now, what are seasonal winds? These are winds which change their direction in different seasons. Now, for example, seasonal winds are the monsoon winds in India. So now you can see these monsoon winds during the rainy season. The winds are blowing from sea to land, and after the rains are over, they blow from land to sea. So they keep changing their direction in different seasons. The third type of wind are the local winds. They blow for a short time during the day and over a small area. So these are called as local winds. Now, for example, local winds are land breeze and sea breeze. So you can see here are the local winds, sea breeze and land breeze. So when does the sea breeze blow? You can see during the daytime when the land is warm, warm air goes into the sea and cool air from the sea takes its place. Okay, so this is sea breeze, and the opposite happens in the night. The sea is warm, so warm air from the sea blows into the land and cool breeze from the land blows into the sea. Okay, so this is the local winds, okay, which take place over a small area during the day. Another example of local winds is the loo. Now the loo blows in the northern part of our country, especially during summers. Okay, so it's only during the summer season that we have this hot winds, which is called as loo, which blows in the northern part of our country. Another important factor of weather and climate is moisture. Okay, water is absorbed in the air through the process of evaporation. How does the water comes into the air? By the process of evaporation. So how we can define moisture? It is the presence of water in the air is known as moisture. When water evaporates from land or water bodies, it becomes water vapor. Now the rate of evaporation is more. When is it more? When the air is hot, dry and windy. So you see children, on a hot day when it is very hot, we tend to sweat a lot. Now when is the rate of evaporation less? When the air is cold, moist and calm. Now why does air that contains water vapor has low temperature? It is due to low evaporation. So you see children, on a humid day, clothes take a longer time to dry. Why is this so? And when it is humid, we sweat a lot, and that sweat does not evaporate from our body easily. Now what is the reason behind this? Yes, the air already has a lot of moisture in it, okay, and then it has no more capacity to absorb more vapor, okay, and that's the reason when there is too much of moisture in the air, then clothes do not dry up, and when we sweat, and this sweat does not get evaporate easily. Children, let us look into the role of water vapor in the atmosphere. Air rises, and when does air rise? When it gets heated, and when it gets heated it becomes light, expands and it rises. This hot air, when it reaches the higher altitudes, it becomes cool, it changes into water vapor, into clouds, and then into small drops of water. The process of changing water vapor into water droplets is called as condensation. Now when these clouds which are carrying droplets of water become too heavy to float in the air, they come down as precipitation. The other name for precipitation is the liquid form, when water vapor changes into water droplets and then comes down into liquid form, which is called as rain. Children, there are three types of rainfall. Now, which are the rainfall? There's cyclonic rainfall, orographic rainfall, and convectional rainfall. Now, when does cyclonic rainfall occur? It occurs when cold air and warm air meet. And when they meet, warm air, because it is lighter, it rises up, okay? And cold air sinks down. So you see children, warm air rises, okay, goes up, cools and condenses, forms clouds, and then precipitates as rain, okay, and then rain is accompanied by thunder and lightning. This kind of a rainfall is called as cyclonic rainfall, where cold air and warm air meet. Cold air being dense sinks down, warm air rises up, cools and condenses, and precipitates as rainfall with thunder and lightning. It is called as cyclonic rainfall. Let us now understand the cyclonic rainfall, which is also known as frontal or depression rainfall, better. Okay, so you can see when warm air and cold air meet. Now, like in a battlefront, what happens? Two armies come from opposite direction and they meet. Okay, that is called as a battlefront. And here when they meet, this red line that you see is called a warm front. Like we have battlefront, this is the warm front. So where they meet, what happens then? Let us see. So warm air, when it meets the cold air, what happens at the warm front? Yes, warm air rises because it is lighter, it rises, goes up, and cold air cools, it cools, goes up and cools, and cold air descends because it is dense and heavy, it descends down, and this warm air then cools, condenses to form clouds, and then its further cooling leads to precipitation along this warm front, and here we will have heavy rainfall with thunder and lightning. So this kind of a rainfall is called as cyclonic rainfall, frontal rainfall, or depression rainfall. The second type of rainfall is called as orographic rainfall. Now, what is orographic rainfall? It takes place when a mountain or a hill comes in the path of moisture-laden winds. So you see children here, the moisture laden winds are obstructed by a mountain, and since they are obstructed, they drop all the rainfall on one side of the mountain. That is why it is called as orographic rainfall. They are unable to cross to the other side, and that is why the other side does not get any rainfall, and this area, the other side, is called as the rain shadow area. Let us understand the orographic rainfall or relief rainfall. Now, evaporation of water from the oceans takes place. Yes, warm air rises, it's filled with water, and when it is obstructed by a mountain, okay, as they are rising, the air is cooling. Now it becomes, condenses, forms clouds, and becomes very heavy, these clouds, due to further cooling, and so they drop all the rainfall on the water moisture laden wind side. Okay, this is called as the windward side. Okay, so on the windward side all the rain is dropped, and the other side the clouds are unable to cross through, so that is called as the leeward side. It is also called as a rain shadow area. They don't receive any rainfall. So such type of a rainfall is called orographic rainfall or relief rainfall, whenever there is an obstruction by a natural feature like a mountain. So the third type is the convectional rainfall, which is normally found in the equatorial regions. Now this is a simple rainfall when Earth's surface becomes very hot, hot air rises, okay, becomes light and goes up to the higher altitude where it cools. So you see the warm air reaches the troposphere, it expands, loses its heat, condenses and forms clouds. You can see after it forms clouds, it becomes heavy and then it rains. So such kind of a rain which happens when the earth's surface becomes too hot, warm air rises, cools and condenses and precipitates is called as convectional rainfall. Now let us understand the convectional rainfall better. You can see when the ground is heats up, what happens. Warm air rises, it rises further and goes and then cools and condenses and forms clouds, and once it cools it precipitates as rain. Okay, and normally it is found in the equatorial region, where it receives the direct rays of the sun. So here you can see that the ground gets heated up due to the sun rays, warm air rises, goes up, cools, condenses, and then it becomes so heavy that it precipitates here. So this is called as a conventional rainfall. So children, with this we end our chapter on air. I hope you have understood all the concepts. Please do write on my comment section if you want further clarification on any of the topics. And till then, do view and subscribe, and I'll be coming up with my next video soon. Thank you.